Um, we are going to talk about Newton's first law of inertia. I am pretty sure that all of you, I would guess that all of you have heard of the law of inertia before, whether it was in another class at Leiden or even in middle school science. So who can tell me, either in the chat box, I'll pull up the chat box, or in just shout it out. What is the law of inertia? Nobody?
Isn't it the law of motion?
So it does have to do with motion. Um, Anybody have anything else to add to that?
Isn't it like not moving?
So there, it can be. It can be when an object is not moving or moving. Um, so here, I'll give you probably like the middle school version of inertia that you probably learned. You just either are too shy to say it or maybe you forgot. So the middle school version of inertia that you probably learned was objects at rest stay at rest. Objects in motion stay in motion unless acted upon by an outside force. Does that sound familiar to you guys?
Yes.
Yeah. Okay. So we're going to change it up a little bit because your understanding of physics is a little bit more sophisticated. So we're going to say it this way. We're just going to say objects maintain their state of motion unless acted upon by an outside force. And really, when we say objects maintain their state of motion, what we're saying is like if it's stopped, it'll stay stopped, right? But if it's moving, it'll keep moving in a straight line. So what do we call that quantity um, that combines speed and direction? It starts with a V.
Velocity.
Thank you, velocity. So another way of saying this that might even be shorter, right, is that objects maintain their velocity unless acted upon by an outside force. So if an object is moving, it'll keep moving in a straight line. If it's stopped, it'll remain stopped, right? But any object, it'll maintain its velocity unless acted upon by an outside force. That is the first law of inertia. And I will share these slides with you guys.
I have a question.
Yes.
Um, when you said that it's in a straight line, is it always gonna move in a straight line?
Yep. So here, an example of that is that you guys probably have seen, maybe have seen, is think about a hockey game. All right. Now, if you when the ice is really flat, the zamboni comes out, makes it look like glass, right? If I take the puck and I shoot it, right, or I just hit it with my stick, that puck moves in exactly a straight line from where I shoot it. All right. Now, why does it do that? Because there's no forces that are pushing it side to side, right? Once the puck leaves my stick, there's no force acting on that ball except for a tiny little bit of friction on the ice, and so it just keeps moving at the same speed in a straight line. And so that's why, like in games, if you'll see a team pulls their goalie and the other team will like tap the puck towards the goal on the other side, you can see it go all the way across the ice, just like in that straight line, while the players race after it. The only time it would curve, you guys, is if there was a force that was pushing it. Now, in real life, the reason that you don't think that things move forever in a straight line is because there is a force that acts on almost um, all objects at all times. That force it's the F word. Does anybody know what it is? Nobody knows the F word? Friction. It's friction, right? So friction slows almost everything down in real life. Or air resistance, those kinds of opposing forces. Now I'm going to go to the next slide. So we actually have a way of measuring inertia. An object's mass is equal to the amount of inertia that it has.
Wait, so the object's mass equals inertia's what?
So an object's mass equals the amount of inertia.
Oh, okay.
Right, so the more massive an object is, the more inertia it has. The less massive it is, the less inertia it has. And you could think of inertia, right, as a resistance to a change in velocity. So, like I said, another way of thinking about it is the more massive an object, the more inertia. The less massive an object, the less inertia. And because inertia is the resistance to a change in velocity, right? If an object has more inertia, it's harder to change the velocity of that object. If an object has less inertia, it's easier to change the velocity of that object. So can I go forward a slide? Okay, 1 second. I'm waiting.
Okay, I'm good.
Okay. So now let's play a game of would you rather, right? So let's say that you're running down a hill or standing on a hill, right? Would you rather, and I'm going to have everybody type their answer in the little chat box, right? This will be our class quiz, right? Would you rather have a boulder roll over you if you're on the hill, or would you rather have a pebble? So just type your answer in the chat box. So I'm a little bit disturbed, you guys. Either you don't understand physics, or I am a mandated reporter, so I have to. If you have a suicide death wish, like I need to talk to you. If that boulder rolls over you, you will not survive that, right? Like look at that person and look at this boulder. If the pebble hits you, it might hurt, but you'll be okay. Now, why the difference? Because this boulder has a lot of mass, right? Which means it has a lot of inertia. Because it has a lot of inertia, it's really hard to change its velocity. When it hits you, it's going to maintain its velocity for the most part, meaning it'll just roll right over you, squish you, and keep going, right? So if you don't want to be squished, you want that pebble to roll down the hill and hit you. Because the pebble has very little mass, when it hits you, it's easy to change the velocity. It might sting, right? You might say, ouch, but you can walk away from that, right? Can't walk away from the boulder squishing you. Does that make sense? I hope.
Yeah.
Okay. All right. Good. So let's do another round. I think you guys are going to get the second round right. Okay. Oh, dodge it. That would be good. You might be able to dodge it. So here's the second round. Would you rather be at a red light behind a fully loaded semi truck? You guys know what that is. It's like one of the 18 wheelers. It has a big load in the back. Maybe it's loaded down with metal weights. I don't know. Leaving Life Fitness or something. So would you rather be behind that semi truck, or would you rather be behind a motorcycle? So I got 3 votes. 4. See, everyone pretty much has this one right, right? Um, so unless you want to take your time and just kind of chill behind the truck, you want to be behind this motorcycle, right? The reason is motorcycles have very little mass, all right, especially compared to semi trucks. That semi truck, you guys, has an engine that's like an order of magnitude bigger than the motorcycle. But because it has so much mass, it's hard to change its velocity. If it has a velocity of 0, it's hard to get it up to speed, right? The motorcycle, because it has so little mass, especially compared to the truck, it is much easier to get it up to speed. It's easier to change the velocity. So the motorcycle goes pretty fast off the red light. The truck goes pretty slow. Your car is somewhere in between them, closer to the motorcycle than the truck. So you won't be able to go as fast off the line as that motorcycle probably, but you can get out of that red light. So now here's the last one. Okay. Let's say that you're following a vehicle. Hopefully not too close. Hopefully you're not tailgating, right? But you're following a vehicle. Would you rather be behind a semi truck that slams on its brakes or a motorcycle that slams on its brakes? Which one would be safer? So type that in. So you have to choose one. It can't be none. But I am, so this one, you guys, I'm a little bit surprised. Again, you're like 50-50 on this. Okay. I'm going to ask you this question. So let's say that you are tailgating one of these for whatever reason. Which one can stop faster, right? The semi truck, the fully loaded truck that has a lot of mass, right? Meaning a lot of inertia, or the motorcycle that has a lot less mass and a lot less inertia. So which one can stop first?
The motorcycle?
The motorcycle absolutely is going to stop faster, right? Which means that if you're on its tail and it slams on its brakes, you're very likely to hit it because your car cannot stop as fast. Your car has more mass than that motorcycle, right? So it's actually harder to change the velocity of your car than the motorcycle. So if it slams on its brakes, you're probably going to smash into it. Whereas the truck, it's very hard to change the velocity of that truck. So if it slams on its brakes, it still takes a long time to stop. You'll be able to stop behind it and not hit it. Assuming you're paying any attention at all, right? In fact, if trucks hit their brakes too hard, you may have heard about this. It's they do what they call jackknife. They actually kind of twist and fall onto the ground. It's bad, right? So anyway, you can stop if the truck slams on its brakes. You can't stop if the motorcycle slams on its brakes. And if you've ever been in an accident like this, you know that's true. I was unlucky enough to be behind a motorcycle. A dog ran out in front of it. So it slammed on its brakes, and I luckily did stop in time. I was behind him. But the car behind me did not stop in time, and he smashed into me and pushed me into the motorcycle. It was a bad day for all of us. But, that's why you have to keep a certain distance. In driver's ed, you learned about that, right? Like at least 2 car lengths. If it's a motorcycle, it should be at least 3. Because you just can't stop that fast. So is this making sense so far? I think most of you guys know this. Yeah. All right. So let's give a few more examples. All right. So I want to know, you have a shot put, you have a baseball. Now, not everybody knows what a shot put is. just it's for track and field, right? It's a field event, and it's a really big, very heavy sphere. All right. I think the women's Olympic shot is 11 pounds. About, I think it's 5 kilos. We'll check in a second because I know I have a picture. Baseballs are significantly smaller, right? So which of those two is going to have more inertia? Shot put or baseball?
Which one hurts
Right.
more?
The shot put is going to have significantly more inertia, right? It will be much harder to get that shot put to change its velocity. And how much harder? Well, here I have two world class athletes. All right. Michelle Carter, she won gold medal. Oh, the women's shot in international competition, you guys, is just under 9 pounds. All right. So she threw this 4 kilogram shot put, and it left her hand at 13.5 meters per second. That's roughly 30 miles an hour. Right. Um, Giolito, when he pitches today, he's going to have an average fastball speed of around 95 miles per hour. I think Giolito's pitching. Might be Kukul. I don't know. So they're both really good athletes, but it doesn't matter how good of an athlete you are. If you can throw this baseball at a much faster rate than you could throw that shot put. Why? Because it is much lighter. It has much less inertia. So it's easier to change its velocity. They both start out at zero, and you're changing their velocity and getting them up to speed. Okay?
Mr. Butman,
Yeah.
but wouldn't getting hit by a baseball hurt way more?
No, actually, if you got hit by that shot put, and we probably won't be able to talk about this till second semester. There's something called momentum, and this momentum gets transferred into an object when it collides with it. This shot put actually will provide a much bigger force at that speed than this baseball. In fact, it would be life threatening if it hit you, especially if it hit like your head. Yeah, it's crazy. It's crazy to think. I mean, she's taking a 9 pound sphere and throwing it at like 30 miles per hour. It's so hard for me to believe that a person could do that, right? Yeah, it's crazy to think about that. But baseballs, and you guys know, baseballs do really hurt when they hit you. But all the time. I shouldn't say all the time, but baseball players get hit routinely during the season and most of the time they just walk to first base. If you got hit with a shot put, you would not be walking to first base, right? So anyway, and I don't know if you see this, but look at the motion of the throw for the baseball player. They put their arm back, and they can extend their arm, right? When they throw this, they extend it over their basically over their head. The shot put, if you see how she has to throw this, she will not extend her arm out like this. What she'll do is she'll push. You push that shot. If you tried to throw a shot put like a baseball, you'd probably, if you did it as hard as you could probably only do that one time, because then you would damage all the muscles, ligaments in your arm. All right? That has to do with inertia. Let's do another example. So there are two inertial safety devices in your car. Okay? Who can give me the most obvious one, the first one?
Seatbelts?
Of course. So you have a seatbelt, right? That seatbelt is an inertial safety device, you guys. If you hit something, so you're driving down the road and you hit something, that seatbelt will keep you in your seat, right? If you're not wearing it, you're going to smash into the windshield, the dashboard, the steering wheel, one of those things. Could cause serious injury, right? What is the other inertial safety device?
Airbag?
So, of course, everyone thinks it's an airbag, right? But airbags are actually not inertial safety devices. They're safety devices, but they work because of something that we're going to talk about second semester probably, and that's momentum. All right. So does anybody else have an idea? So if I hit something going forward, the seatbelt keeps me in my seat. There's a safety device where if you get hit from the back, it protects you.
It's not the bumper, right?
No, but that's
Okay.
another good thought. That has to do with momentum as well. That's another safety feature in your car. Have you guys ever heard of whiplash?
No.
No. Okay. So
Wait,
whiplash.
like on a car?
No. Well, whiplash happens to people sometimes when they're in accidents, car accidents. If you ever seen someone like with a neck collar holding up their neck, they had whiplash. Um, and that can happen when you get hit from behind if you don't have your headrest set properly. So you guys, that headrest is not for looks. It's not so that like you could go back, in your seat or anything like that. Your headrest is actually a safety device, and if you don't have it set properly, you can get a worse injury if you're in an accident. So let me explain how that works. Okay, so I'm in my car here. What was
So
that?
you're not supposed to be sitting like all the way back.
No, no, no. Yeah, so you are. You should always be sitting all the way back, and your headrest should be close to your head. All right.
But like, does it matter if the seat's like, you know how you can adjust your seat like
Mhm.
to go back or more forward?
Right.
Does that matter too?
It doesn't really matter. You should just pick a spot that's comfortable. The further back you are, actually, the safer it is because, and we'll talk about this. When the airbag, most cars now have airbags. So if the airbag deploys and you're too close, usually what happens is you get a broken nose,
Oh.
right? Because the airbag is getting pushed at your face at a pretty high rate of speed. So if possible, it's safer to be a little bit further away from the steering wheel or the dashboard. But if you have short legs and you have to be close, like you got to be close, right? But so let's say that this is me, my crazy hair in the car, and if I get hit from behind, you guys. So let's say I'm stopped at a stop sign. If I'm stopped at a stop sign, my body is stopped, right? My body is at rest, and my body will want to stay at rest. But the problem is, if I get hit from behind, that's going to push my car forward, right? And if my car gets pushed forward, if I don't have my headrest behind my head, this is what happens. The seat is behind your whole body, right? From your shoulders down, pretty much. And so the seat is going to push your body forward, and your head will end up trying to stay at rest because it's not, if the headrest isn't pushing on it, your head will try to stay at rest, and when it tries to stay at rest, it'll end up getting pushed back, right? You'll feel like it's getting pushed back, but that's not actually what's happening. Your body is getting pushed forward. It's getting jerked forward. And the problem is that your neck muscles are pretty strong, but they're not that strong, and it's really easy to strain them. So if you could even do this at school, you guys won't be able to do it when you go back, right? Because you'll have to maintain 6 feet away from your friends. But all the time I see kids in the hallways like jokingly push their friends in the back, right, as like a joke. And I don't know if you've ever thought about this, but when that happens and you're not expecting it, you feel like your head's snapping back. Your head's not actually snapping back. Your body's getting pushed forward, and your head's trying to stay in the same spot it was because of inertia, right? But what'll happen is you can strain the muscles in your neck, and that's what's called whiplash. So when you get hit from behind, it's important that you have that headrest so that your head gets pushed forward along with your body, and it doesn't stay behind. Now, if you hit something in the front, that's when you need a seatbelt, because if you're moving forward, right, you in the car are moving forward, and you come to a sudden stop. If you're not connected to the car, your body will keep moving forward at the same speed in a straight line. So let's say that you were even just doing 30 miles per hour down the street. If you get distracted and there's a stopped car in front of you or someone pulls out of their driveway or anything could happen, right? If you slam into that person and you come to a fairly quick stop with your car, um, if you're not wearing your seatbelt, if you were doing 30 before, your body's going to keep wanting to do 30. And it'll keep moving in a straight line until it has a force that acts on it that stops it. That force could be provided by the windshield. It could be provided by the steering wheel or the dashboard or the airbag. All those are bad, right? If you're not wearing a seatbelt and the airbag deploys, it's going to be bad. You're probably going to go to the hospital at the very least. And you could die from that because the airbag is coming at you and you're coming at it. It's a bad combination, right? And in fact, that's why it's kind of annoying. But when you put something like, say, in your passenger seat that's kind of heavy and you try to drive with it, if you don't actually buckle the seatbelt, the car will keep dinging at you, right? If it's a new car, and it'll keep flashing the airbag deactivated symbol, because if it was a passenger that was in that seat and they didn't have their seatbelt on and the airbag deployed, they could be seriously hurt or killed. So I don't know if you guys ever noticed that before, but that's to protect people from, when they're not wearing their seatbelts, from getting even more seriously hurt. Okay, so does that make sense so far? Yeah. All right. So let's give another example here. Since the Bears are doing so well right now, right? At least they have 3 wins. I want to know, what body type makes the best football player? So is it people who are really big, people who are medium, or people who are smaller? So type your answers in. Type your answers in the box. I got one right now for big. Okay, I got a lot of answers. You guys are all over the place, and you're all right. But I have to say, Alejandro is the most right. Okay, so when I ask which is best, big, medium, or small, I would have to say it depends, right? It depends on what you're doing on the field. It depends on what your job is. So let's look at 3 Chicago Bear players. Okay, we have running backs and receivers. Running backs and receivers, in general, are a lot smaller than other people on the field. Now, I said smaller. They're not small people, right? They're still big, but Tariq Cohen, hopefully he comes back next season. He is only 176 pounds, right? And I say only, that's still a big person, but he's only 176 pounds. I may weigh more than him. I'm sure he's stronger than I am and faster, right? But why would it be more advantageous for him to be small? Well, this picture kind of shows why, right? If you're small, that means you have less inertia. And if you have less inertia, that means that you can change your velocity more easily. So if I was running in a straight line, it's a lot easier for me to change direction, because when I change direction, I'm changing velocity, right? So smaller people can make those like fast cuts. They can change direction. They can actually change speed. So they can go from a stop to full speed a lot more quickly than a bigger person. So these like super speedy people, running backs, receivers, cornerbacks on the defense, they're usually under 200 pounds. Okay, or right, just under 200. Now, if you're a linebacker, linebackers are the medium-sized people in football. So Danny Trevathan, 231 pounds, right? Now that's bigger, but it's not super huge. Why would he want to be 231? Well, sometimes he has to take on linemen that are coming at him and they're really big. So he wants to have enough inertia that he can, he can kind of basically stop them from moving, from coming at him, right? But he needs to be quick enough that he could run from sideline to sideline. He can try to run down these little speedy guys, catch them maybe, right? And then there are people on the field that are from 300 to 400 pounds. Those are the linemen. Those are big guys, right? They're very large people. Why are they so big? Because they have to have a lot of inertia. If you're an offensive lineman or a defensive lineman, you want basically you don't want to be moved, right? Offensive linemen don't want defensive linemen in the backfield. They want to sit in one spot and not let people be able to push them around. The defensive linemen, not only do they have to be strong enough to try to push them around, but they also there are many times when they want to stop the run where they have to stop these offensive linemen from moving into the defensive backfield, and they just want to stuff the line there. So it totally depends on what job you do, how much inertia you have. In fact, you guys, what you see more and more now in certain sports like basketball, lots and lots of basketball players get stress fractures now. And the reason that's happening is because basketball players have gotten bigger and bigger. When I was a kid in the 70s, there were basketball players were always fairly tall, but their weights they were skinnier than they are now. Guys now, like you look at Zion Williamson, like he's a really large person. He's big. He's over 200 pounds. If you're playing basketball and you're making those fast cuts, you're doing you're changing direction, you're changing speed, and you're that big and you have that much inertia, it puts a lot of stress on your body. Because in order to change velocity, there has to be an outside force applied, right? And sometimes those forces that their muscles can provide are actually so big that they'll cause their bones to break. Now, they're not bad breaks. That's why they're called stress fractures, but they actually have hairline fractures in their bones because they just have so much inertia and they can provide such big forces to their bodies. So does all of this make sense? I mean, that is the first law of inertia. You could boil it down to if you have more mass, you have more inertia. If you have more mass, it's hard to change your velocity. If you have less mass, it's easier to change your velocity. And basically, what inertia is, it's the resistance to an object's change in velocity. That's it.